All right, so this is going on page 51 when we're done. We're going to look at polynomial inequalities. So I'm going to walk you through what we're going to do, and then after we do one, I'll kind of explain to you why we care and how else we're going to apply this besides just to polynomials, because it is something we're going to use. All right, so step one is to write the polynomial inequality in standard form, a form where the right-hand side is 0, so that's already done for us right here. And basically that means you have to set it equal to 0. Then we have to find all real zeros of the polynomial, and that's pretty simple, especially since it's already factored for us, something that we're capable of. So our zeros are going to look like this. My smallest one is -4, then 1, then 3. Okay? And remember, if it said x-intercepts, those would be ordered pairs, but it says zeros, so we are good with our set notation. So step 3 is to plot the real zeros on a number line, dividing the number line into intervals. And so that's what this space down here is for. And so I'm going to draw in my number line. Okay, let me redo that. I'm drawing a line that's maybe a little straighter here. Okay, so there's a line. And oops, I'm going to plot my zeros on there. So when I do this, I don't have to put every single little hash mark on there. I just need to start off somewhere and say, okay, well, if this is -4, right, then it could be like -3, 2, 1, 0, and then a 1, and then 2, and then maybe 3 could be right about there. All right, and I'm going to plot them on there, and it says dividing the number line into intervals, so I've made where the numbers are, but then I could have, even though this is less than 0, it could be any of the 4 inequalities that you're used to, and these are the only places where it can change signs. Since this is less than 0, that means it isn't, these are going to be open circles. If it was less than or equal to 0, then it would be closed circles. And I am going to rewrite this right here, down here, so I can scroll up. You don't necessarily have to rewrite yours because you can see yours, but once I scroll, I can't see it. So x minus 1, x plus 4, less than 0. Okay. So you can kind of think of your number line as the x-axis. These are the zeros, right? And so that's why they're on the x-axis. That's when y is 0. And we are going to look at whether or not these intervals of our function would be positive or negative. So we do that. It says to choose a test number that is easy to compute with in each interval, substitute the number into each factor, and determine the resulting sign. Now, let's read that again. Substitute the number into each factor and determine the resulting sign. It does not say determine the resulting number, because I don't really care about what the actual number is. I'm going to determine the resulting sign, and we construct a sign chart. So I have 3 factors here. Okay? These are each our factors. So I have 3 factors. I know that when x equals -4, then y is 0. I'm here on the axis. So I'm going to look at what happens when it's less than 4. So I'm going to pick a number like -5. So I substitute in -5, but not really substitute it in. If I substitute in a -5 in here, -5 minus 3 is -8. All I care about that, I don't care about the 8. I just care about the fact that I get a negative number out. My -5 goes in here, -1, that's still a negative number. -5 substituted in here, give me a -1, so it's still a negative number. Because the value itself doesn't matter. What matters is I get 3 numbers out, they're each negative. So when I multiply negative times negative times negative, I end up with a negative number. So when x is less than 4, my function is negative. So then I'm going to choose a number in between here. Well, 0 falls in here. If you can choose 0, 0 is always a good one to choose. So 0 minus 3, that would be a negative number. 0 minus 1, that would be a negative number. 0 plus 4, that would be a positive number. So negative times a negative is a positive, times positive is positive. So then I choose a number in here. Choose like 2. So I substitute in 2, it's going to be negative. Substitute in 2, it's going to be positive. Substitute in 2 here, and I'm going to get positive. So negative times positive is negative. Then I have to choose a number on the other side of 3, so like 4. Substitute in 4 here, it's going to be positive. Substitute in 4 here, it's positive. 4 here, it's positive. So my function, negative, it's going to cross the x-axis, then it's positive between negative 4 and 1, then it's negative here, then it's positive here. Okay? I know that the signs are alternating. You may be thinking, oh, well, they're just going to alternate every time. That is not necessarily the case. I know that that happens here, but if it was that easy, then I'd just tell you to find the first one and they alternate and bam, you're done with it. But that's not what's happening. So what I'm looking for here then is, it says, form the sign chart. This is my sign chart. Sign chart's important because that's what we're going to apply to things that other than polynomials. Shade the parts of the number line that satisfies the inequality. Well, if I want this right here to be less than 0, that would mean negative. So a shade where it's negative, that's where it would be less than 0. Then write down the solution of the original polynomial inequality in interval notation. So this right here, what I've shaded, goes from negative infinity to negative 4. I never include my infinities. This is an open circle, so I do not include negative 4. If it was a closed circle, it would be a bracket. And then it's negative again here from 1 to 3. Okay. So some applications of this. We are going to use this with rationals as well. Same idea, because we need to know what's happening with the function, positive, whatever. They've already been using this in calculus. It's something that you will use in calculus. When you get into calculus, you're going to talk a lot about this particle that's on the x-axis and it moves left and right. Okay, and so if you're looking at a graph of the velocity function, or you have, let's say that this was an equation for the velocity function that went along with your particle moving left and right, then when the velocity function is positive, the particle's moving to the right, and when it's negative, it's moving to the left. So it might ask you, on what intervals is this particle moving to the left? So you would need to know to make your sign chart, and then it would be these intervals right here, because that's when it's negative. But of course, your velocity functions aren't always necessarily polynomials like this, but that's kind of the same idea. So sign charts are going to be applied to many different things. The concept is the same. The difference would just be whatever is given to you here. Okay, so let's do a few more. A couple of different things are going to happen. So it says, same thing, show the solution of each polynomial inequality on a number line and in interval notation. So here's my number line. Well, maybe. There we go. Here's my number line. This is already factored for me. That is fantastic. So I need my solutions. So x is equal to, my smallest one is going to be negative 3. That gives me this one. This gives me a 0. This gives me 1. Okay. So I have negative 3, 0, and 1. Okay. So then is greater than or equal to, which means these are solid. Then I'm going to make my signs. So something that is less than negative 3, we'll go with negative 4. Negative 4 in here would give me a negative number. Negative 4 in here gives me a negative number. Negative 4 in here gives me a negative number. Negative times negative is negative. Substitute in a negative 1. Here gives me negative. This, negative, then positive. Negative times positive, positive. Then I have to substitute in something in here. 1/2. Oh no, it's a fraction, but it's fine because we don't actually care what the numbers are. Positive 1/2 right here will give me positive. Positive 1/2 right here is going to give me a negative number, and then positive here, which makes this negative overall. Then here I could pick 2, so this is going to be positive, positive, positive. So what I'm looking for here is when the function is greater than or equal to 0. So that means I'm looking for when it's positive. So I'm going to shade this, shade this. Then I also have to write it in interval notation, so I'm going from -3 to 0. And these are closed circles, so these are brackets, they are included. And then from 1 to infinity. Never include your infinities. Okay. All right, next one. So here, one of the differences is that I have a negative here, and this negative here is like a -1 being multiplied. It doesn't have an x on it, but it's a -1. I'm going to draw in my number line. Okay, I need my zeros. So it's going to be -2 and 3. So a -2 and a +3. This is just greater than, so open circles here. Now here's what you want to pay attention to. You've got this negative sign out front. So although I only have 2 sets of parentheses, I'm actually going to have 3 signs in my sign chart. The sign that I get out of this factor depends on the x that I substitute in. It varies because this is a variable. This doesn't vary. It's -1. So no matter what's happening, I'm going to have to multiply by a -1. So that negative sign is one of them. I have 1, 2, 3 signs that I have to take into account here. So my first sign is going to be negative because it's a -1 no matter what happens. Then I'm going to pick a number like -3. So -3 minus 3 is still going to be negative. Then -3, I substituted in here. It's going to give me a -1, but when I square it, it becomes positive. No matter what I substitute into here, when I square it in the end, this one's going to give me a positive number every single time. So for this one in particular, I'm going to start with a negative and end with a positive in every single case because of what's happening here. So when I substitute in a number here, like 0, okay, so this is a -1, so that's a negative no matter what. Substitute in my 0 here, that gives me -3, so it's negative. Then this one right here, well, it's going to be positive no matter what happens. Oh, I forgot to do what's happening here. Negative times negative is a positive. Negative times negative, positive. They did not alternate this time. And then 4, if I substitute in a 4 here, this -1 is just negative. 4 in here would give me a positive, and then this is positive no matter what. So here is my negative. So I want this to be greater than 0, which means it's going to be positive. So I'm shading here and here. So I want you to think about what this little X, when it does when you're sketching. That's a bounce, right? That's when it's tangent to the axis. So that means my function is positive. It's 0 here, but then it's going to bounce back up and still be positive. So that's how you get your bounce in there, and it goes positive and then it stays positive. We want this to be greater than 0, so that's what I've shaded. So I'm going from -infinity to -2. It's an open circle, so they're both parentheses, and then from -2 to 3. All right, so let's look at number 3. So number 3, get my number line drawn in. Oh, why my pen's not working? There we go. All right, so my zeros are going to be -4, 1, and 2. So I'm going to graph these. -4, 1, and 2. And then this is less than or equal to, so these are solid. Right? And again, see how many signs I'm going to have. This gives me 1 sign, 2 signs, 3 signs. This is like a -1. That's my 4th sign. So your first sign is going to be negative in every single instance. Then if I choose like a -5 here, -5 minus 2 is still negative. -5 plus 4 is a -1 to the 3rd power is still negative. Odd powers, the signs stay the same. Then this is squared, so this is positive no matter what's happening. So your last sign is positive. First one's negative, last one's positive, every single time. So start with a negative because of this. I can, in here, substitute in a 0. So that's negative. 0 be positive. Substitute in a 0. Well, this is going to be positive no matter what. Oh, negative times negative times negative is negative. Negative times negative is positive. Then I'm going to substitute in a number here. So it'd be like 1.5. So I know I start with a negative. Then here, 1.5, that would give me negative still. This would be positive. And this is going to be positive no matter what. So this is positive here. Then if I substitute in 3, I know I'm starting with negative. Then this is going to be positive, positive, positive. So it's negative overall. Then I need to shade. I need it to be less than or equal to 0, so I'm looking for negative. Right there and right there. So I'm going to go from negative infinity to negative 4. Oops. But that is a closed circle, so that's going to be a bracket. And then from 2 to infinity. And there you go. All right, number 4. So what makes 4 different than the others is that I have a negative like I did on some of the others. Here, I have a couple of things going on. This right here is not in the order that I would like it. I want x to be first, and I need to factor this. Okay? So let me start by getting my number line on here. Okay. So I'm going to start rewriting this. So I'm going to have negative and then x minus 1. I'm going to flip this around because I want x to be first. But I can't just flip it around and leave the signs. That's going to be negative x plus 3. Then I'm going to need to factor this. So this is x to the 4th, but I can treat this like a quadratic. So it's going to look like this. This is going to be x squared and x squared. This is negative, so the signs are opposite. So I need two numbers that are going to multiply to give me negative 4, combine to give me a negative 3. So it's going to be a positive 1 and a negative 4. And check myself. 1 times a negative 4 is a negative 4. Then that's positive x squared, negative 4x squared, gives me that negative 3x squared. It's greater than or equal to 0. Okay, so now I'm going to need to continue to factor and clean this up a little bit. So I'm going to rewrite negative and then x minus 1. Now this right here, I don't want that to be a negative x. So I'm going to factor out a negative 1, so it's going to be x minus 3. When I factor out that negative 1, it comes out here and multiplies with this, so it actually becomes positive. This x squared plus 1 stays x squared plus 1. This is the difference of squares, so this is x plus 2, x minus 2. So there's a difference of 2 squares, there's not a sum of 2 squares, so I can't do anything with that. Greater than or equal to 0. All right, so I'm just going to box this so we don't lose it in all the other mess that I wrote. So there is my fully factored form, and then I need my zeros. So my zeros are going to be, see, negative 2 is my smallest, but that gives me a negative 2. This gives me a positive 2, so I can actually just make that plus or minus 2. This is going to give me a 1, then a 3. Then I want to look at this right here. Well, that's actually not going to give me anything I can use, because if I do x squared plus 1 and set it equal to 0, that means that x squared equals negative 1, so x equals the square root of negative 1, right? Remember that that is it's an imaginary number. So it's actually plus or minus. And that's an imaginary number. Now, I can't plot that on my number line. Plus, if you go back and look at the front, number 2 doesn't just say find all zeros. It says find all real zeros. I don't care about the complex or imaginary numbers. All I care about are the real zeros that I can actually graph. So when I get a factor in here that I can't use, like I can't get anything out of, it's still important and I have to use it. I just can't put anything in my real zeros here. So that's all I've got. So I'm going to come plot those over here. I have negative 2 and then I have a positive 1, positive 2, and positive 3. Then I have to plot my points. This is greater than or equal to 0, so these are solid. Then I got to find my signs. I've been doing my signs horizontally, but there'll be quite a few, so I'm going to be doing these vertically. But let's look at how many signs we're going to have. I'm going to get one from this, one from this. Even though I didn't get a real 0 out of this, I'm still going to get a sign. Like when I substitute in numbers, things still happen. And one from here, one from here. Since that ended up positive after I factored out that negative 1, that's no longer an issue for me. So that means I'm going to have 1, 2, 3, 4, 5 signs that I have to look at. So I'll start with a number like negative 3. Substitute in negative 3. This is still going to be negative. Negative 3 minus 3 is still negative. Negative 3 squared, positive plus 1. But let's think about this. Is there anything I could substitute into this that would make a negative number come out? And the answer to that is no. Because once I square it, it's positive, and then since I'm adding 1, it just becomes more positive, so that's going to give me a positive every time. So my third sign, positive every time. This one, when I substitute in my negative 3, still going to be negative. This one would be negative. So negative times negative is a positive, times a negative, times a negative is all positive in the end. So then I can substitute in 0. So substitute in 0, and my first sign then would be negative. This would be negative. Third sign is always positive because of this. Then this is going to be positive. This one's going to be negative. So negative times a negative is a positive, but then times a negative makes that negative overall. So then I can substitute in like 1.5. So 1.5 minus 1 is still positive. This would be negative. Third sign's always positive. That would be positive. 1.5 minus 2 is going to be negative. So negative times a negative is positive. Then 2.5. So I substitute in 2.5 here. This is going to be positive. This would be negative. Third sign's positive no matter what. This would be positive. 2.5 minus 2 is positive. So when I multiply all those together, it's negative. Then I can substitute in 4. This is going to be positive. This would be positive. Third sign is positive. 4 in here would make that positive and positive. So this section here is positive. All right, so I am looking for where it is greater than or equal to 0. That means I'm looking for the positive intervals. So this one, and this one. So I'm going to go from negative infinity to negative 2. I am including the negative 2 because it's solid. Then I'm going to go from 1 to 2, including them both because I have closed circles. Then I'm going to go from 3 to infinity. Okay, there's my answer. Kind of ran into my x's over here. Oh. Well, shoot. I don't know why it won't undo. It doesn't like me. Okay, well, I was trying to fix that, but I don't think I can. So just want to make sure you could see that that was a parenthesis. All right, and there you go. Pay attention to, remember, all you care about is the signs and what you're multiplying together. The values themselves don't matter. I will show you tomorrow how to kind of connect this to some other stuff that we have, but right now we're just looking for where these are positive and negative.